What's up, my clankers? Today we're going to be doing the last web chall from CyberSpike 14, Corporate Doohickey. It's a funny chall because it's more rev than web. So let's hop straight into it, right? So writing the binary, let's do some funny revving. Alright, here's the main function. Yada yada yada. Oh, is this the main function? Yeah, here we go. And so we got sock handling, path handling, right? Basic stuff from a web server, nothing too crazy. However, there's nothing really any suspicious, so if we go search for HTML, we can find all the HTML being stored in row data, right? And so if you read through this HTML, you can see something called R doohickey, right? And then that's one of the paths that we didn't see in the main function. So let's take a look at it. Here's a normal web server, and doohickey, right? So we enter this login portal, and so usually for login portals, what we want to do is check for any type of injection, right? So maybe inject into an SQL database, no SQL database, or just a database in general. Maybe inject some HTML, who knows? There's a lot of injections involved with portals. So let's just take a look at the source and see what we can find. So let's scroll down. So looking through the functions, I found these. Here we go. And I know this one is the handler for the portal because looking for username and password, right, from the URL encoding. Scroll down here. A lot of interesting stuff. First thing I noticed, encrypted flag, right? We'll come back to this later. This is a very funny thing that we can do later. And so, going further down, we do some handling, right? If you look here, this is probably this decodes the flag. And we got a variable called vulnerable HTML. Yeah, that's I don't know. That might be the vulnerability. We might need to check that out. And so if we scroll down here, right, keep scrolling down, we find that we can inject any type of string we want here, right? And then it gets shown in the template. And so that's dangerous because we can do something called parameter injection. And so from low-level languages like C, we can put parameters like percentage %x, percentage %n, so on and so forth, that allows us to access the stack directly. And so if we can access the stack directly, that means we can read variables also on the stack, like this flag. So let's test it out. Let's go here, and let's just put a bunch of A's just to know where we are, and then just start calling a bunch of pointers. Send the request. Let's take a look at the responses. Here we go. So we got our A's, and then we're starting to go through the pointers, right? So the first one, second one, third one, so on and so forth. However, if you decode this pointer, it will give you a ASCII value of GALF, which is flag backwards. And so this is actually what we're looking for, because the file itself is LSB, which is least significant bit or byte first, also known as little endian, which means that instead of going it from left to right like we're usually used to, it's going to be from right to left. And that means we're on the right track. So what we do next is, spoiled it a little bit, we call all the pointers after so we can read the entirety of flag. So send this request, scroll down, and we get all this fun stuff. So starting from where we get flag, we copy this to the very end, copy it, and then let's try to decode this. Little spoilers ahead. So here we go. We just need to clean the data up a little bit. So we gotta get rid of the OX's, and then we get rid of the null bytes. Because remember, it's LSB, meaning this would be from right to left instead of left to right, meaning G would be here, and then A, L, F, and then everything else that came, I think, before it, right? Yeah, before it. So this would be null if there was nothing before it. So let's get rid of this. Now let's take a look. And so, yeah, it's the same answer here. I'll even refresh it so just in case. Yeah, we got the same thing. And so since we know it's LSB, we can just flip it around, right? So GALF, we get flag, and then braces, where, and then we do underscore, and then what's the next part? The beef, and then flip it around. This. We can get rid of the star because it's past the flag format. And so we get the flag. Where's the beef? So that's how you do it with the web part, the web way, right? And the non-cheese. Now, let's get into why we're here. The cheese method, right? We love cheesing. And so, yeah. Sorry, had to a little interruption in the middle of that. So let's go back to the cheese, right? What we're here for. So we have the encrypted flag right here, and then we have a function. Where is it getting called? Decrypted over here, right? So let's take a look at this function. Single by XOR. It's almost like this has been done repeatedly throughout the entire comp. That's crazy. Can we check what is being passed? The number 42. It's almost like they referenced it in the HTML multiple times. Let's try something funny. How about let's take a look at this. Oh, I spelled single wrong. Lamau. Just so I know that I'm right. Cat single. Okay, so we have our string, we have the key 42. And what happens if we just XOR it? Damn, we get the flag. And so that's how we do it the cheese way. You don't even you can completely skip the parameter injection. So yeah, that was the last web chall. Not really web, more like Rev hiding in a web trench coat, but it was fun regardless. Leave your comments and questions down below. I'll be sure to answer them. Thank you.